When we are, once we know how to add or subtract rational expressions, once we know how to do the multiplication, once we know how to identify the non-permissible values, we can now solve these equations. Many of these equations will involve the use of adding and subtracting expressions. You will be using lowest common denominator for all of them. And once you simplify the expressions here, likely you will end up with a quadratic equation. You will end up seeing square, and you will be solving those equations using the quadratic formula. Or you'll be able to factor your trinomial if that's the case. So here is example number one. If one wants to solve an equation like this, looking at the question here, it consists of three parts. Part number one, part number two, and part number three. Some of them consist denominator, others don't. But technically, in this case, you can consider that as 2 over 1. When we are to solve rational expressions, we want to make sure that everything can be factorized. If they can be factorized, you can then move on to the next step, which is get rid of the denominator. We don't like working with denominator. If we can remove the denominator earlier, it will be easier for us to solve this equation. So compared to what we saw in the previous lesson, adding and subtracting rational expressions, getting the lowest common denominator for everything, we want to remove the denominator. And we're going to remove each denominator using the lowest common denominator. Here is what we will do. Let me copy the question from the above first. And I'm going to leave some space in between each of them. Because I'm going to do something extra to this equation. Looking at the denominators, we have x minus 4 in the denominator. Here is x minus 4, here is x minus 4, here is 1. The lowest common denominator, in this case, would then be x minus 4 and 1. Well, I don't need to write the 1 here. If this is the LCD, instead of making everything with the same denominator, this time I want to remove the denominator for each of them. And I can do that by multiplying each of them using the LCD. I'll times it by x minus 4, I'll times it by x minus 4, and I'll times it by x minus 4. And I only multiply the numerator for each of them. I will only multiply the LCD to the numerator for each term. But I'm not going to expand it. The purpose of using multiplication here is to reduce it with the denominator. Multiplication and division, they will offset each other, and therefore, once you multiply everything by the LCD, the things in the denominator will be gone, making your equation a lot easier to solve. So we end up getting 5x for the first one, 2x minus 8 for the second one, you expand it, and finally 3x plus 8 for the last one. No more denominator. This is a lot easier to solve compared to what you saw at the beginning. Sometimes we end up with a quadratic equation. In this case, we have a simple first degree equation. No square involved. I can simply group the like terms together and solve for x that way. I'll bring the 3 to the other side, and then I'll bring the 8 to the other side, giving us x equals 4. Once you've solved the equation, ask yourself if this is possible. If it is possible to use x equals 4 for the question itself, make a substitution. Put this number back to the question itself using x equals 4. And if it turns any of your denominators to a 0, we have trouble. We want to reject. That's the time when your non-permissible value will be so useful. We learned non-permissible values back in lesson number 1. At that time, we didn't know why we are getting the why we were finding those. That's why we are doing it. The non-permissible values will help us to identify values we don't want to use in case it actually will give us the same answer. We need to reject those values. So in this case, we will have no solution at the end. Because your solution has been rejected.